Hi, welcome back to 30 Days of Python. Today is day 14 and we're focusing on higher order functions. This is where the function block of code takes precedent in Python. It gets treated like first-class citizen that allows you to pass it around, return it, and manipulate its data. So this makes it easier to write clean modular code. So like I said, in Python, functions are first-class citizens, which means they are assigned variables, passed as arguments to other functions, returned from other functions, and stored in data structures. As seen here, it demonstrates how functions are used in each of these ways. This might be a bit of a head scratcher at first, but it makes your code very powerful. Think of them as reusable building blocks that can be used to rebuild structures again. The same way will apply to your code. So it'll like a house essentially. So what exactly are higher order functions? Simply put, they are functions that take one or more arguments or can return a function as a result. Let's take the first part here. This takes the function as an argument. As you can see, the function process data has parameters, data, and processor. As seen when being returned, it uses comprehension to loop through each item given to the process. When used, you can then call the function with your arguments like normal, first giving the data, then indicating the processor involved. As you can see, the variable numbers is a list of numbers. This is the data that will be looped through, while the processor is a function of squaring each item in the list. When called, the output will read out in the open brackets. The second case of this function is used by the string function and capitalizing each word. So it loops through each of them, in this case each word, and then capitalizes it. Now we look at how higher order functions can return a function. This is kind of like a nested function, a function within a function. Each function has its parameters. Create logger with level and logger with message. Let's look at the first one. We can see its function is to print out a string with the variable. It uses the parameter from the first function, create logger, and run a function .upper to capitalize the argument given to that parameter. Then carries on printing the rest of the message. In order to understand its use case when it returns, we need to first declare a variable that calls the first function and sets in the argument. In this case, we're creating specialized loggers called info and error. This is what will be capitalized. Then the rest of the print statement will be printed with the parameter being used as the variable input here as the message. Notice the indentation of the return. It is not below the print function inside the nested function. Rather, it's below the nested function. This allows us to call the function or return it as a result to then be used. Now let's look at the final part of the usage of the logger functions. The variables info logger and error logger acts as functions now, and in the place of the arguments we place our message. So now we can see we can go backwards up the code instead of down the code line by line. The message is passed to the variable info logger because it's assigned the call function of create logger with the arguments info and error. Since we call the first function create logger, it passes the first parameter in, which is now used by the second nested function logger, which we now take in its own parameter, which is now passed into the message when we pass the argument in info logger or error logger. Like I said, it is a bit of a head scratcher at first, but once you get the hang of it, it will make sense. Python has built-in higher order functions. This is map, filter, and reduce. Let's take a look at how they work. The map functions takes in two parameters, a function and an iterable item, like the numbers list we have here. Using lambda, we can assign the variable x to represent the item in the list and iterate through the list. We then pass the second argument, our list, that will be iterated. In this case, the function is squaring the item in the list. Since it's an iterator, we output them as list, or else the IDE will not output the result, or will throw a warning error to convert it into a list to get an output. If you're using named functions, this higher order function can call inside the function just like before, with the function and the iterating item. As seen, when called, we use a list as our argument to meet the parameters of the function. The filter function takes in the same parameters like map. However, this function returns all items in the list that returns as true to the function. Like this function that only returns the items in the list that has a modular of 2 that equals 0, hence the variable being even. When called, the output will print out the list of all even values inside the original list, numbers. The reduce function is imported from a functools module in Python 3. The function applies functions cumulatively, like the function to multiply x by y in the product variable. When called, the output will not be a list, even though the parameter needing to be met is the exact same as the other functions, map and filter. Here the result will be the cumulative outcome for multiplying each value in the list of numbers by one another. The same can be said for the sum using the reduce function. Let's revisit the lambda function quickly. We know they are small anonymous functions defined in a single line, but they are perfect for higher order functions. Look here, a simple lambda function to square a parameter given the argument is assigned to a variable. When called, the argument is given and the result is the square of that value. With multiple parameters, the same principle applies here. With the sorted function, we can take in the key value pairing from the list students. In use, we now specify the list or iterating variable we wish to use and call the function in the second parameter. In this case, we are sorting the list by student grades, so the key we're specifying is grade. Using the lambda function for each student with the key grade is being called. The sorted function then outputs it into a list format from lowest to highest in the ascending order by default. Now, comparing the sort function to the filter function, we see that the iterating list is moved to the second parameter rather than the first. This is due to the function's behavior. The sorted function already outputs as list, whereas the filter does not, and we have to convert it. We can be complex with our functions, but if there is too much complexity in the code, rather use a named function instead for a better readability in your code. Let's go over some coding patterns you can expect to build using the higher order functions. Function composition. Like a math equation, g of f of x, or function g given function f given x. In any case, this applies a new function for f, then g. In this case, if we were to add 1 to x, then attempt to square the result of x plus 1. We create a variable that takes the assignment of the function compose, taking in the argument add 1 and square. When the complete function is called, it will take in the value x. The addition function is done first, then the squaring. Look at partial functions. Imported from the func tool module, we can create specialized functions like changing the exponential value to fit our needs, like the squaring and cubing function here. When called, we can input the argument from the base value and get the result output, since we have already altered the parameter for the exponent. Looking at decorators, these are higher order functions that allows users to add new functionality to existing objects without modifying the structure. In order to use a decorator, we need an outer function with an inner wrapper function. We take the defined function timer that imports time. It contains an inner wrapper function and prints out the timing function information. It returns result, and then the timer function returns the function wrapper. To use the decorator, we use the @ symbol followed by the function's name. The decorator function is a higher order function that takes in a function as its parameter. At the end of this, we get the result of the timing function. In a real world scenario, like data processing pipelines, in other words, how programs like Jenkins and repositories like GitHub interact with one another. These are pipelines that process user data with multiple filters and transformations. If we look at the function process user data, we can see it applies all filters and transformations to the given parameters. In this case, there is only one, users. Since users is a list of dictionaries, we can apply the filters and transformers based on the key value pairing. We can then assign it to a variable and print out the results. When we call the function with its arguments in place, from this example, there should only be one output fitting these conditions. The second use case is configuration-driven behavior. We can define a function and set dictionary variables containing math operations. We can then return the function dictionary and specify the key value by using the function get, specifying parameters and its values. When being used, we call the function with the argument being the key item in the dictionary. Since the dictionary's value pairing contains two parameters, we give it our two arguments. It should then do the mathematical operations we specified when calling the defined function. This type of coding makes your code flexible. You can change behavior without changing logic when passing different functions. So, what's the difference between list comprehensions and higher order functions? Well, it's the use case of them respectively. Take the example of the list variable numbers. Both sets of functions will output the same result. However, it comes down to complexity. Higher order functions are best used in reusable code that is complex, while list comprehensions is best suited for simple transformations. You can pause and look over this example here. The code where higher order functions shine best under complex code. Both have their place. List comprehension are often more readable in simple cases, and higher order functions is used for reusable code. A more telling place for higher order functions are in game development, when one function needs to be reused and modified slightly to fit needs of objects or characters. For best practices, when implementing higher order functions, is having readable lambda functions. Having overly complex functions is not ideal for lambda functions. Using named functions is best for complex logic, and using meaningful named variables is also good practice. You do not want to be unclear in your naming. Remember, readability counts a lot. Using higher order functions for complex code to make it clearer, not clever. And that's that for higher order functions. If you feel like you've gained something from this video, leave a like, and if you want more content like this, please subscribe. We're moving on to day 15, where we are going to deal with Python type errors. Cheers everyone, I'll see you then.